Hello, welcome to Engineers Mindset. So to follow up our series on implicit functions of multivariables, let's consider we are given the problem. Let x cubed exponential y plus z minus y sine x minus z equal to 0. Define z as an exponential function of x and y. Question says, find the partial derivative of z with respect to x and find the partial derivative of z with respect to y. Okay, now let's bring out the function and see. We have x cubed exponential y plus z, okay, minus y sine x minus z equals 0. Okay, and we want to differentiate this function looking for partial derivative of z with respect to x. Okay, now I've always said, of course, we have here s cubed multiplying exponential y plus z. So these two, we are going to simply apply the product rule of differentiation. And you know the product rule of differentiation, simply from product rule, you know, if z is equal to u dot v, okay, and I said to differentiate z with respect to x, simply you keep u constant, okay, then you differentiate v partially with respect to x, plus now you keep v constant, then differentiate u partially with respect to x. This is a product rule whenever we have two variables multiplying each other. So we are going to now apply this rule to solving this problem. We might not necessarily state these rules. I just want you to understand that you consider this rule to be what? Two functions. This x cubed now simply becomes u. And this exponential y plus z simply becomes v. So which means from the rule, keep u constant, which means we are going to be keeping x cubed constant and then differentiating the exponential function y plus z with respect to what? X. Okay, plus now you keep the exponential function, which is y plus z, constant, which is here, and then differentiate x cubed with respect to x. That's how we're going to do that derivative. Okay, now let's do it and see. All right, so from the rule, keep x cubed constant, so I simply have x cubed. Okay, I'm now differentiating exponential y plus z as a single variable with respect to x. All right, so please, I did a video on how to differentiate exponential functions by a shortcut approach. Do well to look up the series for proper understanding. But to differentiate exponential function now, okay, so that is the first law. We are going to apply product rule for differentiating these two functions. Okay, secondly, also notice now that I am differentiating with respect to x. I want to find partial derivative of z with respect to x first. So which means I'm going to be treating every other variable that does not pertain to x as simply what? A constant. I'm starting with partial z, partial x. So I'm differentiating only variables that contain x, and I'm also differentiating z only with respect to x. So which means I'm going to be treating y here as what? A constant. So the same treatment I give to every constant when differentiating is the same treatment I'm going to be giving what? Y here. Okay, now let's apply these rules now and see. First of all, I need to differentiate these two functions using the product rule. And from the product rule, you know, keep x cubed as constant, so I simply keep x cubed. Now, I am going to differentiate the exponential function. I have exponential y plus z. Please, I did a video on shortcut approach to differentiating an exponential function. You may wish to want to look up the video for proper understanding. But in that video, I said, to differentiate an exponential function, first thing to do is simply differentiate the power of the exponential function. Whatever you obtain when differentiating the power of the exponential function, use that derivative to multiply the exponential function itself. Here, the power of the exponential function is simply y plus z. So this becomes the power y plus z. And I want to differentiate this function with respect to what? X. Since I'm differentiating with respect to x, it means I'm going to treat y as what? A constant. So if I differentiate y, automatically I will have 0 because the derivative of every constant is simply 0. And then I will differentiate z partially with respect to what? X, because this is what I'm looking for. So I will simply differentiate z with respect to x. So the derivative of this power now simply gives me what? Partial z partial x. Use this derivative to multiply the exponential function itself. That gives you your derivative. So we simply have partial z partial x, which is the derivative of the power, multiplying by the exponential function y plus z. So I keep this aside. Okay, so that is the first part. Keep x cubed constant, differentiate the exponential function. Now you're going to have plus, remember the product rule, plus you now keep what? The exponential function constant, simply exponential y plus z. You now hold it as constant. Then you differentiate what? X cubed. And if I differentiate x cubed with respect to x, this is simply x cubed. I will simply have what? 3x all squared partial x all over partial x. So I simply have this. Okay, so I've been able to differentiate this part of the function completely. Next is now to differentiate what? The second part of the function. So simply minus. Same thing happens here. I have y multiplying by what? Sine x minus z. So y is simply multiplying this. So I'm still going to employ what? The product rule of differentiation to differentiate these two functions. And from product rule, I'm going to keep y as constant. So simply hold y as constant. Then you differentiate what? Sine x minus z. So then again, I did a video on shortcut approach to differentiate what? Trigonometric functions. So you may wish to look up the video for also proper understanding. But I'll also explain it here. Of course, I have sine x minus z. This is what I want to differentiate now. Sine x minus z. And I said in that video, to differentiate a trig function, the first thing to do is to differentiate the angle in front of it. That's the very first thing to do. Differentiate the angle in front of it. Use that derivative to now multiply the derivative of the trig function itself. So the angle in front of it here is simply what? X minus z. This is the angle in front of what? The trig function. If I differentiate x with respect to x, of course, I will simply have 1. If I differentiate x, I will have 1. That is simply saying I'm differentiating x with respect to what? X partially. So that gives me partial x minus, if I differentiate z, which is also what I'm looking for now, with respect to x, I will simply have partial z all over partial x. So this gives me the derivative of what? The angle. Partial x, which is same as 1, minus partial z partial x. So I said, use the derivative now to multiply the derivative of the trig function itself. If I differentiate sine, I will simply have cos. So that means I will simply use partial x all over partial x minus partial z all over partial x to multiply what? Cos. Then put back the angle x minus z. So this gives me the derivative of what? This function sine x minus z. Okay, so I will now plug it back into what? The law now. Keep y constant, which is this, differentiate sine x minus z, and this derivative simply gave me partial x all over partial x plus partial z all over partial z all over partial x cos. I have x minus z. Okay, so I simply have this. Okay, so I simply have this. All right, so next, after keeping y constant, differentiate this, you now keep what? Okay, just to segregate this, because y is multiplying everything here, and this negative sign is multiplying the entire bracket. Okay, I will bring this down a bit. So next is plus. Okay, now you keep the trigonometric function now, which is sine x minus z, and then differentiate y. Of course, if I differentiate y, I'm simply going to have what? 0, because the question says find partial z partial x, which means I'm keeping y as simply what? A constant. And since there is no x variable attached to y, there is no z also attached to y, it means the partial derivative of y with respect to x automatically gives us what? 0. So this is actually multiplying by 0. Okay, so I have this. The whole of this is equal to 0, not forgetting, equal to 0. Okay, so we can now evaluate or expand the bracket. If we do this, we simply have f Okay, so let's now evaluate this. I have here x cubed partial z partial x exponential y plus z. So simply x cubed partial z partial x exponential y plus z, okay, plus here I have 3x squared. Please take note, partial x over partial x is simply what? 1. So I have 3x squared times exponential y plus z. So this simply gives me 3x squared exponential y plus z, okay, minus, okay, open a bigger bracket y. All right, so here I have, please take note, partial x over partial x is simply 1. 1 minus, here I have partial z over partial x, all over partial x, okay, cos x minus z, cos x minus z. So take note, sine x minus z multiplied by 0 is completely off. Everything here is 0. So that's all. So the whole of this is now equal to 0. So I have this. Okay, so let's bring out our terms. Let's now expand this bracket here. We can expand this, evaluate this. I have 1 minus partial z partial x multiplying y and multiplying cos x minus z. So I will simply start with multiplying, expanding this bracket with simply cos x minus z first. Okay, so I will simply have x cubed partial z, x cubed partial z all over partial x exponential y plus z plus 3x squared exponential y plus z. Okay, I have that. Next is minus. Okay, let's now expand this bracket with simply cos x minus z. Cos x minus z multiplies 1 gives us cos x minus z. Cos x minus z multiplies partial z partial x. Okay, gives us cos x minus z partial x. So I simply have minus y into, this is now simply cos x minus z, okay, plus cos x minus z partial z all over partial x. So the whole of this is equal to 0. Okay, so I can now expand this bracket with simply what? Y. And if I do that, I have here x cubed partial z all over partial x exponential y plus z, okay, plus 3x squared exponential y plus z minus, so minus y multiplies cos x minus z simply gives us minus y cos x minus z, okay, minus y multiplied by plus cos x minus z partial x simply gives us minus y cos x minus z partial z all over partial x, and this is equal to 0. All right, so all I will do at this point is correlate all the terms that have partial z and partial x, simply like collecting like terms. I have partial z partial x here, I have partial z partial x here, bring them together. So I'll simply have x cubed partial z all over partial x exponential y plus z, okay, now minus y cos x minus z minus y cos x minus z partial z all over partial x, okay, and here I'm left with plus 3x squared uh, exponential y plus z, okay, and then minus y cos x minus z. This is simply equal to 0. So I have this. At this point, all I will simply do is factor out what partial z partial x, since is common between these two. Factor it out. I will simply have x cubed exponential y plus z, okay, minus y cos x minus z all into partial z all over partial x. Okay, so I have this plus, this is now 3x squared okay, exponential y plus z, okay, cos minus y cos x minus z, and this is equal to simply 0. Now, this is what I'm looking for, partial z, partial x. Next thing to do at this point is simply what? Send these variables here over to this side of the equation, okay? So if I do this now, positive sign crosses an equal to sign gives me a negative value. So I'll have here left x cubed, okay, exponential y plus z minus y cos x minus z, all multiplying by partial derivative of z with respect to x, and that's simply equal to. So if this crosses over here, I will simply have, okay, so plus 3x squared exponential y plus z crosses over here becomes minus. So I simply have minus 3x squared exponential y plus z, okay. Here, minus y cos x minus z crosses over here becomes positive. So I simply have plus y cos x minus z. So I have this. Since I'm looking for partial z, partial x, I will simply divide both sides now by what? S cubed exponential y plus z minus y cos x minus z. So that's how to make partial z, partial x subject. Therefore, partial derivative of z with respect to x is now simply the whole of this term divided by the whole of this term. Simply I have, all right, let me take it up here. So partial z all over partial x is now equal to simply the whole of this term, which is minus 3x squared minus 3x squared exponential y plus z plus y cos x minus z plus y cos x minus z all over the whole of this term x cubed exponential y plus z, okay, minus y cos x minus z, okay. All right, guys, so that becomes the answer to that partial derivative with respect to x. Okay, so I'm going to cut the video here and I will do the second part of the question, that's partial z, partial y, in another video, just to avoid too much lengthiness of the video. All right, guys, I hope you find this video very, very interesting and educative. Please, if you do, don't forget to share your thoughts in the comment section, like the videos, and of course, if you're new to the channel, please hit the subscribe button to keep getting updates on content like this. Thanks, guys. I will see you in the next video. Cheers.